So starting with myself, my name is Krishna. I'll be your instructor for this session. So starting with today's topic, our today topics is static and probability for data science. I would be talking about the key things here which actually are useful for data science, and I will be putting more focus on that. So this is going to be our agenda. We will talk about what is the probability for data science, then statistics for data science, then hands-on. Now, before I jump onto probability, I don't want to ask you about probability. What is statistics? Okay, let me give you a feel of what is statistics is. So I'm not sure if you are aware, at least go back to 30 years back. If people want to study in a particular state, how many people have only two children, this family planning and all. So only two children in order to study. I'm not sure whether you're aware. They used to send some set of people to home. Mostly they are all some teachers or whatever. That's what they used to do, at least in my state. In other cities also maybe similar setup. Some representatives from the government or private organization, they used to send people to each home. And those guys used to note down on the paper like over how many family members are there at your home and how many of them are children. Are you having two children or one children, like that? Now think like what they are and why they are doing all this is to understand how their state population is. Is it like their state population? Do they have average? Every family, can they say on an average in my state every family has two children? On an average in my state every family has one children? How can they tell that information unless they go and check each and every home, right? So what they do, they actually set up some set of people like this, and each guys will go to homes and collect the information. And do you think in the entire state for how many days it will take? It will be too much of time consuming task, right? Going to every home, knocking the door and getting this information and all. It's not practical enough also. So they used to do some sampling kind of thing where they used to go to certain regions which actually represents your population kind of thing, and they'll not go and knock on each and every home. They try to do as much as possible, but as we all know, it's not practically possible. So let's say in a state there are 30 cities again. In each of the city, maybe most of the crowded area, most of the places where people live, they will mostly go there and collect the information. And the people where there are less people are there, they will go to one or two homes, something like that they will do, so that they can finish the survey in time. So if you see what they are doing here, what they are doing, if you look at is to answer a question, to say is every family in my state has two children or one children, or is every family in my state, are their kids employed or unemployed? Lot of information you can derive. All that what they are doing, they are studying your information, or they are studying your data about your family. So statistics is exactly that. Statistics is a study of data where, why do you do it? You study the data to analyze. That means what you're trying to do, you from the data, whatever you collected, you're trying to understand what is it. Then you're trying to understand meaning from it. When I say meaning here, okay, once you get the data, first you will try to analyze to see, okay, how many families have two children or one children, like that you keep studying, which is the analysis part. Then once you analyze, you try to get meaning of it. When I say meaning, on an average across, because you cannot sum it, right? On an average, what do I see? I see most of them having two children or one children. That's how you do it. That is your interpretation part. Then finally you derive some insights or conclusions in the sense where you say that, hey, I have seen out of 100 families people have surveyed, there are like 90 families who have two children. The other 10 might have one or no kids at all, but doesn't matter. The 90 means they're like huge number. That means 90% of the families have these two children. That means that's a good number. So you can say on an average in my state, everyone has two kids, right? So that's what you can infer, saying every family has at least two kids. Like that you can infer. That does not mean that you're saying absolutely. It's more about approximation. So what you are doing is here you are studying the data in order to analyze, interpret, and get some sense out of it, or get some meaning out of it, or get some insights or conclusion out of it. That's exactly statistics. Statistics is nothing but a study of data to analyze, interpret, and gain some insights or derive some conclusions from it. That is statistics. And in statistics, there are two high level branches of statistics. One is called descriptive statistics, another is called inferential statistics. We have that here. So here, descriptive statistics, in the sense the statistics which talks about how do you describe the data. That's why it is called descriptive. How do you describe data? Given that lot of data given to you, how do you describe it? You can describe in different ways. You can describe by showing in a tabular forms, nice tables. That is one way. Or you can describe a data by giving an average measure. If I ask in a class how many people are getting, if I ask a teacher in a class what is your average class mark, she will give me one number saying 60 or 70. She will not say Ravi got this, Alan got this, like that. She will not tell each and every member. She will get to give me one number. That is also one way to represent the entire class marks data, which is average measures. Another thing could be you can put a nice graph or pictures. So this way, where you are using either graphs or tables or some kind of average measures or central measures, you can say, to describe some data, is called descriptive statistics. Whereas the other part of statistics, which I called out, inferential statistics. Inferential statistics is, since like our example earlier, like deriving how many children each family has in my state, since you cannot do for the entire population, you will collect from set of regions or specific regions you choose based on some criteria, which is nothing but a sample. From sample, if you are able to infer what's going to be the estimate, like from sample, if you are able to derive the insights of the entire population, that's called inferential statistics. Inferential means based on something you should be able to infer, and that is where your probability comes. This probability theory is part of inferential statistics. And why it is more important? Probability is very important when you do this predictions, machine learning, all that, because every machine learning you see, you always say my model percentage accuracy percentage is 90%, 2%, 90%, 70%, 60%. You never say it will perform 100%. There is, every machine learning algorithm you see, it always comes with an approximation measure. You cannot perform 100% as of today. So what they are doing, they are giving you approximate. And how they work internally, they work internally using these kind of probability measures or other mathematical things. So that's why probability is very important if you are going to learn about machine learning. But if you are working mostly on data science side of it, then you need to have good amount of knowledge on descriptive statistics and some probability also, but not much. Okay, so now coming to our original thing. So since I set you agenda for what are these key terms, ideally the ordering of this should be, first we should talk about statistics, then we should talk about probability. But since it is flipped, that's why I want to give you a high level understanding of what is statistics, what are the two key areas of statistics, and where does this probability falls into. Like I said, inferential statistics, here it is all about how do you tell something can happen. Like this is a classic example. People will say, I roll a dice and can you tell me what are all possible outcomes? You will give some set of possible outcomes. There could be 6 possible outcomes. It could be 1 or 2 or 3 or 4 or 5 or 6. That is a probability. You are not saying this is what going to happen. You are saying this can happen. That means out of the total outcomes, if you are able to say these are the desired outcomes that could happen, that is what probability is. So probability is more about, if you take a real-time example, if I ask you, will it rain at 10 o'clock today? If I just ask you that question, we really don't know until it happens. But you can always say, based on the past data or whatever, maybe the probability or the chances of it happening could be this. That chances which you are saying, if you can put in a mathematical function, that's called probability is. So like that, people show the tossing coin example or the dice example. It's all about tells you what is the probability. That means what is the chance of getting that outcome out of the total outcomes you have. That's what the main thing here in the probability is. So it's all about certainty. What is the chances of that could happen? And whenever you conduct an experiment to derive something, like if I give you an experiment asking how many people in your locality are educated, that's a question given to you. So now that is an experiment. That experiment, unless you do it, you will not know. That's called a random experiment, where you will predict an outcome based on certain certainty, but you don't know until it happens. Like the rain, whether it happened at 10 o'clock or not, until it happens, you don't know. But you can always say there is a chance of this happening because yesterday at this time, this is how the temperature was. Day before yesterday, this is how the temperature was. But you can always predict some outcome, but you cannot say exactly will happen. Absolutely. So this experiment is called as random experiment, where you say that this could happen. And the possible outcomes, like when you say whether it could rain or not rain, or it will partially rain or it will be cloudy, all that set of outcomes is your sample space. And even you are saying on the experiment, if you say, okay, one chance of happening is it could rain, that one chance of happening that it could rain is your event. It's like that. And if you take an example of tossing a coin, it is like your random experiment would be tossing a coin is your experiment, whereas sample space is the possible outcomes, head or tail, and event is getting a head or a tail. Now there are different probabilities again. You have joint events, disjoint events. So joint events in the sense where what is the probability of two outcomes to happen together, like a student getting marks in 100 in statistics as well as probability of getting him 100 marks in subject like probability also. What is the probability of two things happening at a time? And disjoint events in the sense they do not have any outcomes, like for example the output of ball delivered cannot be a sixer and a wicket. There's these are these two different distinct events. Now, in the probability, you see different types of distributions. Distributions is about how your data is scattered around. So there are like, it could be probability density function. When you put the distribution in terms of a mathematical function, we call it as a probability density function. There is this normal distribution and the central limit theorem. So probability distributive function, like I said, if you are able to represent the data using a mathematical function, you will say it as a PDF as a shortcut. So that's called probability distribution function, equation which describes a continuous probability distribution. Now, normal distribution, this is very important statistics. So normal distribution talks about, here there are one more thing, left skewed and right skewed as well. So normal, this is basically a normal distribution, and sometimes people call it as a bell curve. So what does this says is, if you see the data here, if you say by the height of the graph and by the, how this is called tails, and how these tails are there and how the widespread they are, you can always say what is your average data point for any data by just looking at that graph. You don't need to do anything here. Okay, so here in this case, you can say on an average, since it is exactly a bell curve, you can say this is my average. And sometimes you will not see these kind of graphs. Sometimes you might see this type of graphs also, and sometimes you see this kind of graphs also. It is like left skewed or right skewed. That also could happen. That kind of distributions are also there. Okay, so it's more about from your data without you started doing analysis from the graph. If you are able to say how the data is distributed, you can take help of this. And in Python or whatever language you use, you have certain criteria on how you can actually measure it. These you can actually derive and identify the data from these graphs. So the central limit theorem, the idea here is, if you have a data like very large data, how do you identify whether the data is, how the data is distributed? Is it normal distribution or is it nearly normal distribution or not? How do you identify that? So central theorem, limit theorem, what it says is, rather than you put data points for everything, you take samples for each data. Let's say you have 1,000 data points, maybe take samples of 30 and calculate in that sample the mean of each sample. And for mean of each sample, if you try to put a histogram or a frequency distribution graph, the graph which comes actually says that that will be equal to a normal distribution, or it will tell you how the data is distributed. And here the central limit theorem also says that if your sample size is large enough, that does not mean it is infinity, but if it is so large enough, it will be mostly tend to and show you the actual normal distribution also. And these have some real-time applications. We'll see if the time permits. So there are different types of probability also, like you have marginal probability, joint probability, and conditional probability. So marginal probability is like what is the occurrence of one event to happen. That's called marginal probability. I'll not talk about too many mathematical equations and all. The reason is like, we have to see how in real time they get applied, right? These mathematical functions you can also by heart. There's not a big deal. What I want you to understand is how we can use it programmatically. So that's why I'm just moving towards it. And joint probability is two events happening at the same time. So that's what the joint probability is. Like if you say, I want to know what is the probability of an ace and a king come together, something like that. And conditional probability is, it is like influential factor. Like what is the probability of one event happening based on the occurrence of other. Like let's say, for example, if I say that what is the probability of a person's mood or emotion based on the climate, whether if it rains will he happy, or if it doesn't rain or it's sunny will it be happy or not. So here I'm tying my emotion with the atmospheric conditions going to happen today, something like that. So there's like you're tying up one probability with another probability here. And we have certain formulas for deriving all of it. You have to calculate formula for the first one and the second one. Based on that, you should be able to tell that. And Bayes' theorem is one of the theorem which actually tells about what is the relation between one conditional probability and its inverse as well. And this is like a one real-time application. Let's say somebody came to a clinic, and if they want to test if they have a liver problem or not, how do you identify what is the certainty that that person who has come has liver problem or not is what we are coming to derive as 3.33%. Now, how do we derive it? So first, actually, we calculate the probability saying 10% of patients, I mean, we just assuming 10% of the patients, but before they have come, they might have problems. And the probability that patient drinks can be, let's say, if it is 15%, and the probability that they drink even though they have a liver problem. That means they know that they have a liver problem, but still they drink, there could be 5%. So based on this probability of A and probability of A and probability of A divided by A by B, which is like, this is like a inferential probability where you get this answer 3.33%, which says that the person having a liver problem is 3.33%. It's again certainty, guys. We are not saying it will happen exactly. And like I said, probability, you see the models are nothing but your machine learning programs. All are built based on the probability. In fact, their accuracy, loss, everything is calculated using probability. In fact, using your probability only, you will able to say that whether my algorithm is working good or not, and you can optimize it. So mostly if you see, all these are somewhat related to more or other related to how you actually make your machine learning algorithms work more better. That's the main thing. And data science, if you go after the analysis part, once you have completed everything, after your data visualization and all, once you start with machine learning, probability plays a very prominent role. So if you want to move to a career of machine learning, we should be very good in probability. You should at least understand those terminologies and all that, because they will come now and then like anything. Now coming to statistics, we already discussed about what is statistics. You can see the same definition will be there. Applied mathematics concerned with data collection, analysis, interpretation, presentation. That's what we have said, right? Now, like I said, in statistics, these two are the terms which will come. Population sample. See, population is simple, guys. If I say in a state there are 1,000 people, that is the overall population. Sample is a representative data which is representative of the population. That means, let's say if there are 1 crore people in the city, and I want to know in that how many people, the same question like how many families have 2 children, it is very difficult to derive. So what you do is you actually take a subset of the entire population, and that subset is also very important. It's not like when I say subset, you randomly pick any subset and say that this is how it is for the entire population, because practically to identify this answer from the entire population of 1 crore or 2 crore within the time limit and with less human effort, it's very, very difficult. Right now, how you can finish in less time and much less human intervention is the key. And there people actually take some sample, and the taking sample also has a different strategy. It's not like you randomly pick it, that will have its own bias. You have to choose sample carefully, and generally the recommendation is the sample you choose should be representative of the entire population. That means you have to take a sample in such a way so that you can say, okay, this is what this will represent it. I mean, we are not saying close, but at least it is like moreover an approximation, and it is moreover close to exact value. Okay, but we are never saying it is absolute value. Now, like I said, sampling. When I say sampling, it's not easy. You can have different samplings. You can, there's probability or non-probability classification, but these are the different techniques of taking sampling. Because as we know, calculating the data for entire population is not possible. Now, how do you pick samples so that you can tell the answers to people? Okay, like if I'm in my state, if I want to say like how many people are employed and how many people are non-employed, I cannot go and ask each and everybody home. Even whatever mechanism I use, whether it is from deriving from your social security number and all, I still find some people missing. So how do you identify it? The technique people use in statistics, and that's the same technique applies in data science also, is they take sampling. And sampling, how do you do sample? Again, that's a question, right? You cannot do randomly. That will have its own problem. Now, what are the different techniques to do it? So those techniques are these. Now coming to random sampling, like the name says, random sampling is just like, you choose anybody randomly, like out of the entire population, you choose set of people randomly, and that might sometimes give problems. Sometimes it might be, if you're lucky enough, we might get the relevant answers as well. So that's why you have another sampling where we say systematic sampling. In systematic sampling, what would happen is you choose saying, I will choose every third person, or I will choose every fifth person, I will choose every 10th person. Now, how the 10 or fifth or second person decided, that is again another statistical measure. But here you will choose every nth person to figure out whatever the sampling you want to do. In that, every second record and all. So you choose it, and from there you start your sampling and all. Now in strata sampling, stratum is like a category or a subset. That's what called stratum is. So in strata sampling, what you do is you collect subset. Like in this particular entire population, if I want to know how many are male and how many are female, you choose a strata saying 2 people at a time, and you choose a strata saying male and female subset, and you keep doing it. So it's like collecting from groups, you do it, and on top of it you again apply sampling. So this is what I was talking about, descriptive statistics, and another is inferential statistics. As I already spoke about descriptive statistics, it's more about you describe the data. Descriptive means you describe the data in different forms, using different ways. One by using numerical measures, another by using graphs or by tables. We already discussed. When I say by different numerical measures, it could be average, it could be maximum, minimum, these are all, or it could be some might not be a correct one when it comes to aggregate, but if you take other measures like median, mode might be appropriate. Similarly, inferential statistics is more about making predictions based on the sample about your population. Now, what is the descriptive statistics? Again, descriptive statistics, if you see, it's broken into 2 categories. One is measures of central tendency, another is measures of variability. So measures of central tendency is nothing but how do you describe the data using some measures, numbers. So here the name just focus on central tendency. Central tendency here, what it means is how do you identify the midpoint or the center point of the data. That is what measures of central tendency talks about. And in that, there are different techniques to identify it. One technique is mean. Mean means arithmetic mean, or you can say average. Average is not the exact term. We have to say exactly arithmetic mean, where what you try to do is in the entire data, like other example I was stating, like in a class of 100 people, if somebody comes to teacher and ask what is your average class mark, she will not ask each and every mark of the class, right? If the principal comes to the school, she will say what is your average mark of the class. She will give you a number 60 or 70, something like that. So what is she saying is she is giving you one number which is the center point of all the marks of the class. It does not, that 65 does not mean everybody gets 65. That 65 means that most of them have the marks which is closer to 65. That is your midpoint, or the mean value kind of thing. So those kind of thing, how you identify that central value is what there are different techniques using mean, median and mode, and each has its own application. And measures of variability at a high level, if you see, let's say you have identified a particular measure, a central point you identified. Now from the center point, it's not necessary that all your data points are same, right? Or it's not necessary that all the data points are close. Now, what if I ask you a question from the center point, how much distance each data point has? How do you know about it? And to know about it is what this measures of spread. So measures of spread or measures of dispersion. People put it different terms, but all here you try to identify is whatever measure, like for example, here you identified arithmetic mean of a set of data points. In that particular arithmetic mean, the other values, not every value will be equal to mean, not every value will be closer, but how much distance they have. Are they 2 values distant from the actual mean value? Are they 10 values distant from the actual mean value? That is what these will help you to tell. Okay, basically range, interquartile, those and all will be able to help you. That's why it is called spread or variability. So in measures of center, it's all like calculating the mean of it. It is mean is nothing but simple, just sum of all the data points divided by the number of values. So what we are saying here is most of the values have a center value as 103. But actually, is that true? No, really, right? Some are 1996. So we are never saying it is exact. We are saying most of the values have closer to it. So if you see, most of them are closer to 103.625. If I want to say one number saying, okay, what is your average measure of this data, I can simply give this number. Now from here, if we want to say each value is there, how much difference it is, like 110, it's like 7 numbers different, close to, right? 90, it is not 7, it is like close to 20 numbers. 96, it might be some 15. So that is the distance between that number to this. That's how you derive is measures of spread. Median is again to get the center value only. But here in the case of median, what you do is for a given set of data, you actually arrange the data in a particular order. ascending order or descending order doesn't matter. You have to arrange in a particular sorted order. That's what important is. From there, you calculate the middle value. So if you see here, from this data, first I sorted, it's already sorted. Higher to lower or lower to higher doesn't matter. You have to sort it. After sorting it, take the middle value. So 22.8 is your middle value. That's how you infer it. But let's say if it is odd number value, you will take the middle value. If it is even number, you have to take the arithmetic mean of the middle two values. So if you take the arithmetic mean of middle two values, these two are the middle two values. If you see, for these two, if you calculate the mean, you get this. So you are saying my center value is 22.9. And every measure has its own pros and cons. Okay, I'm not saying every measure you have to use in data science, but every measure has its own pros and cons. Now mode is the measure which tells you what is the most repeated value. Like for example, if you have the data, if somebody asks you, if you have set of data in this particular table, there are set of data. If I ask you what is the mode of this MPG value, you can say 23, because that is the one mostly repeated than anybody else. Okay, that is what mode is, most repeated one. And you might be wondering why you have to study statistics about mean, median and all. What is the importance of it? I will tell you one importance of mode. If you go to Amazon website or whatever, these kind of e-commerce website, how do they know that these are the frequently bought items? Frequently bought items means what? Frequently bought item means the item which is bought by multiple people. That is nothing but mode. And what mode talks about? Mode talks about the most repeated item. So whatever they are saying, the frequently bought is nothing but your mode value. So the same statistical mode is applied there. Just that we talk in English and forget that is a statistical measure. That's the only difference. Okay, so mode is like that. Mode is for frequently purchased items, frequently bought items, or frequently commented items, or frequently frequently liked item, anything. So those are all your mode measures. Applications of mode are like that. Now coming to, it's not speed, it's wrongly given here. It is measures of spread. So like I said, measures of spread is, let's say you have calculated the mean. Now, even you calculated the mean, it's not necessary that not all data points are closer, but how much distance they are from the mean value is what these type of measures help you. Like for example, range. Range is simple. You have to calculate the maximum value and minimum value and take the difference. That's what range does. Whereas interquartile range is all about you break the data into quarters. In median, what you do if you really look at is you sort the data and take the middle value. So with median, what you are actually doing, if you look at is, you are breaking the data into two halves, one half on the right, one half on the left. With quartiles, you actually break the data into quarters. So for example, if these values are there, you will say first you identify, in order to calculate interquartile range, which is Q3 minus Q1, what you do is first you calculate the middle value, which is like median. After calculating the median, what you will do is you will get two halves. Like if let's say for example, these numbers are shuffled somehow. Let's say this is our number and this is our median. Now you get two halves. This is first half and this is second half. In this half, you will calculate the median, and that median is 2 here, which is your Q1. You will call it Q1. And again, in this half, you calculate the median, and that median is Q3. The difference of these two will give you IQR, interquartile range, which is in this case is 4. Okay, so that's how you calculate interquartile range, and these have its own application. Actually, this IQR and all are used to identify outliers. So outliers, just to give you an idea, outliers is like when you have a lot of data. In that, if you want to identify what is the value which is not following the data trend, that is where you go for deriving these outliers, so that kind of data you will remove it out. Okay, I'll tell you why it is so important to remove the data, why not and all. So like I said, IQR is Q3 minus Q1. I told you how to do it. And variance or standard deviation is the measure people uses. Standard deviation is just a square root of variance. So what does the standard deviation tells you is, standard deviation, like the name says, it tells you how much each data is deviating from the mean. So the way to calculate is, this is sigma I square. So actually the way we calculate median, standard deviation is, what you do is you do something like this. Let me show you. You do something like this. Let's say you have data points like this. Once you identify mean value of it, let's say here in this case, mean, I'm just saying 1 plus 2, 3, 6, 6 plus 4, 10, 10, 15, 15, 6, 21, 21 divided by 6, 21 divided by 6 will give you something around 3 point something. 6 3s are 18, and that goes in 19, 20, 31, 3 and 6, something like 3.4 or something like that. Once you calculate mean, from there you calculate how much distance it is by using the formula where you actually subtract each number from it, like from the mean, and this is your mean actually. It is like the formula will be something like this: x minus x bar. uh, you you I cannot put the symbol because that's not there available in the keyboard. U means mean it. This x means each data point. You will calculate it and you will square it, so that even if negative value comes, you will take the absolute value of it and you will square it and sum it and divide it by that. That will give you the standard deviation, and after that you will do square root also. So that's how you derive the standard deviation, which tells you how much distance each number is from the mean value. That's what it tells you. Now, these things, entropy and all, before we do it, let's go and understand this hands-on. And I mean, because more than this, other things are important. So now, how do you use this? Like I told you about that mean and all, I'll show you one application of that. Insert code cell. Okay, so see like for example, let's say you have values like this, 1, 2, you have numbers like 1, 2, 3, 4, 5, 6. I just told you about outlier, right? I just want to show you that. Now, if you see here in this data, if I calculate the mean of it, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, and divided by how much? 1, 2, 3, 4, 5, 6, 7. This will give you the average value or arithmetic mean, right? So it says your arithmetic mean is something. It will tell you it connects sometime. After it connects, it would be very fast. This is how the Google Colab is. So it says 4 is the mean. This is, so your mean value is 4. That's what it says. Okay, so your mean value is 4. It was it says. Now sometimes there could be outliers in your data. So what does outlier mean is, this is very important in data science. If I say this is your mean, but let's introduce some outlier here. So if I say the same values, let's say if you have a value called 100, now you calculate the mean of this guy. The same thing, you will get 8 here plus 100. Now print the mean. Now it says mean is 16. That means your center value is 16 is what it says. But is it your center value 16? No, your center value most of the time is 4 actually. Most of the value are closer to 4, but not to this. Just because one value which is way more higher than your original value, that is why the mean is showing up wrongly as 16. That is why in data science, so what is happening is your mean literally got corrupted here because of one higher value. This kind of higher value which is not following your data trend. Your data trend is one, each number is one distance or two distance, whatever. Okay, but they are following one trend. But this guy is following completely a different trend which is not expected. Because of this, your mean got corrupted, and in your analysis, mean plays a very critical role. Let's see if my class marks is this, and because of one guy disturbing, one guy getting 100, I will say my class mark is 16, which is not true. My class mark average is 4. Okay, so since it corrupts your analysis, since it disturbs your analysis, this kind of data ideally has to be removed from the actual data set of points. So that is called outlier. Outlier is a value which is not following the trend, and it is either very extreme means very high, or very low. That means something like a very negative value, minus 15, minus 16, something like that. Those are called outliers. And to identify these outliers and all, we do have some techniques, like in EDA and all, we use some techniques to identify those kind of outliers to remove the data. Okay, and mean is heavily impacted with the outlier, because mean is one considered as one of the best measure to calculate the summation of all the values, because in the mean only you consider each and every data point. If you take median and all, you will not do all that. In this case, if I ask you what is the median, what you will do is you will hardly take the middle value. In this case, the middle value is 4 plus 5. Is that correct? Yes, 4 plus 5. That means if I calculate the median of it, median is something like 4 plus 5 divided by 2. That means 4 plus 5 is, what is the value? 9. 9 divided by 2, which is 4.5. So your median, if you look at it, is not influenced by outlier. Median is not influenced by outlier if you really look at it, right? Okay, what does it say? Okay, it says syntax error. That's okay. Your median is not affected by the outlier. Why? Oh, I am calculating. That's why it is not happy. It want to calculate by itself. So your median is not influenced by the outlier. If you see, that does not mean you should be using median. It's all about situation. In median case, the problem is it will not consider each and every data point. It will just sort the data and take the middle value. So if there are a lot of outliers, then median makes sense. But if it is just one or two outliers, then you have to probably go for mean, because that is the guy who considers every data point and sums it. Whereas the median, no summing, nothing. Just sort the data and take the middle value. That's all. So those are the situations you have to decide whether you should go for mean or median. Mean is the one probably people choose, but if you have a lot of outliers, you can go for median also. Okay. Now that's about the outlier and all. Since that is not there in slide and it is very important for data science, I just want of covering. The same thing you will apply on the actual data and all. That's all. Okay, now what we will do is we will do a small exercise, small hands-on. So this is the data I have. So in order to do whatever statistical measures we have learned, like calculating mean, median and all, we do have certain functions. Okay, and they are all part of library called pandas. And there are some in NumPy also. So I included those two. These are two popular libraries in data science. And I have put the link also from where I collected all this data set. Now this is my data where it have information about name, age, rating. So I created this data where I have this information. On this, I'll calculate the mean, median and all. So if I want to calculate the mean, let's say if I want to calculate the sum, I can just say df dot sum, and df is nothing but which represent this entire data. If I just say df dot sum, I'll get the sum of all the values. It says age sum is 3082, rating sum is 44.92. It just sums it up. Now let's say, I mean here sum doesn't make sense because you're just summing all the ages. Rather than that, you want to derive, let's say, what is the average value, average age of this data. That is more relevant. So average age, if you want to derive, you can just say df dot mean, and that will give you average age is 31. And average, what is the average rating? It says it is 3.74. Similarly, if you want to calculate median, you can even do that. This is the median, which is 29.5, and the rating is 3.7. In this case, they are very close, mean and median. And similarly, you want to calculate mode. Mode, if you calculate, it tells you the mode of these values also, the most repeating ones. So here it says 23, 25. They are the, I mean, if you look at this entire data, okay, these are the ages data, right? If you look at, there are multiple values. 23 is repeating, 25 is also repeating. If you see, if there are more than two modes, if there are more than one mode, and let's say it is two modes, that's called bimodal. And if it is three modes, then it is called trimodal. Like that, you can have multiple modes also. It is always possible to have multiple modes. Similarly, let's say you want to get all the statistical information. You're not just interested in mean, median. You want to look at every other statistical information. Then you have a function called df.describe, where it will help you to show every other statistical measure on your numerical data. So here, if you see only age and rating is coming, this data is text in nature, so it automatically ignores that. So on this, when you say describe, it automatically puts all statistical measures. First one, it put count, how many are there. It says 12 data points you have related to age information and 12 rating you have. It calculated the mean for you, both age and rating. It also calculated the standard deviation for you. It also calculated the minimum value of all the age information and also the maximum value of all age information. It calculated 25 percentile, 50 percentile, 75 percentile also. This is important because your 25 percentile is your Q1, 75 percentile is your Q2, and your 50 percentile is your median. You see this value and this value will be same, 29.5 and 3.79. That is your median basically. Similarly, let's say you are interested in looking at information not only for numerical, you are interested in looking information about two data types. Like if you look at this one, every data, if you just say df.info, all the data I have showed you, it has, okay, it's not defined. I didn't executed it. I executed earlier. Now if I say, this will give me information about what are the column names in your data and what is their data types. These are data types. Object, here the string is all the strings are considered as the type of object. Numbers, integer or float. It says 64 integer bit, 64 float bit. Now in this, I'm interested in only object data type and the float data type. I can even include that. So that way I will get only the information about these two. But let's say I want for everybody, then I can say include all, because like you see, if you just say describe, it will give you only the, consider only the number related columns, not everything. Similarly, if I want to put multiple aggregate measures, so what does it mean by aggregation? Aggregation means if you want to sum it up or not sum it up, if you want to give one single value for the entire data set, that is called aggregation. So that one single value could be maximum value, could be minimum value, could be mean, could be median, could be mode, anything, because these all help you to give one single value for the entire data set. So like that, if you see, what I want here is, I want to get the age maximum, minimum, mean, median, minimum. That's what I'm interested in. I'm not interested in this. So you are very specific on what kind of measures you want on the aggregation part. So you can use this aggregation function and you can give the set of measures you want, and it automatically calculates and gives you that. So what it does is, it applies the maximum function on this age, applies minimum function on this, mean on this, median on this. Similar to that, it will do the same thing for rating also. That way you will get what the metrics you are interested in. Similarly, you want separately standard deviation, you have a function for it also. So till now, if you see, these are all nothing but descriptive statistics only. In fact, representing this information in table, that is one form of descriptive statistics. After that, you calculate the value by calculating mean, median, which is nothing but measures of central tendency. That is also descriptive statistics. Now there is other part of descriptive statistics called putting the data in the form of graphs. That is also one way of representation. That also you can do. So like here, I took a data set called tips. Tips data set is about, this is a popular data set which is part of Seaborn library. It is provided, where it talks about when a person comes to your hotel, I mean, what are the tips they have given? That is what the overall thing is. So it says that, okay, a person come to a restaurant, and whether they did dining or lunch, whatever, on which day they have come, are they smokers or not, what is the family size, is it 2 member, 3 member, 4 member, what is the gender, is it female, male, and what is the tip they have given, and what is the total bill. This is the tips data set. On this data set, I can put multiple plots based on, I'll just put a df dot plot, it will put a line chart for me, where this one shows, this blue one shows the total bill, and this pink one shows the tip, and this one shows the size. And I can derive multiple information saying, if the number of I mean, if I put properly analysis here, I just put a random graphs, but if I properly put some analysis, I can even figure out, is it because if the size of the family is high, are they giving more tip, or is it because the people who are dining, who are coming for dining, are they giving more tips? I have to put on those things. So to understand the relationship between that data, so based on that, what I will do is, maybe I will put, since the tips are coming high during the dinner time, and maybe I'll put more people there. Or let's say I can infer one more information. This is size. Size means how many members are coming to your restaurant. From this data, I can also infer, if I put a proper graph, I can also identify that at what time the family size is coming more. Based on that, I can increase the tables in my restaurant, because let's say dinner time only two people are coming, and the overall count of families, if you count, is not high, but lunchtime you are seeing the families are coming with four people average, on an average. That means you have to create tables which accommodate 4 people, right? Not a 2 people seater. So all those information you can easily analyze from it. These are all information help you to analyze and figure out that, based on that, how should I put it. And if let's say there are a lot of smokers are coming, you should not be saying when you're coming to a restaurant, no smokers and all. And at the same time, you should not be disturbing other customers who don't like smoking. So how do you provide facility for them? And this also you can infer by studying the data by putting relevant graphs here. I just randomly put some graphs here. So it is on the gender and the tip. So on this graph, if you look at, this is my tip on y-axis. This is called a scatter plot, and I have put the gender as the x-axis. So what it says is, males are giving more tips. That's what it says. If you look at, there are a lot of data points on the male side than the female side. Female side, hardly they are giving 7. No offense, just a data. That's what data talks about. Okay, so the male are giving more tips is what the data talks about. That means maybe the guys who are the servers and all should give more priority to mails. That is one thing the data tells us. It all depends on the data. And I have put a histogram also tip on this. So what it tells me is histogram is for frequency distribution. Here what it is trying to tell me is in the entire data set, how many times a tip, which tip is like, what is the tip which is coming? Like for example, here if you see something around 2 to 3 is the tip price, where these servers are getting 80 times. That means on an average they are getting 2.5 as the tip. Can I say that? Because that is what mostly people are getting. That means mostly when somebody joins your restaurant as a server, you can say that if they ask what is the tip I get, from this data you can easily say you will get minimum 2.5. So how do you saying that minimum 2.5 based on this data? Because you see most of the time, 80% of the time, this is where highly dense, right? This is where they are getting a tip close to 2 to 2.5. Like that you can derive a lot of inferences and all. Okay, this is just on that data set. Okay, that's it. I'm done for the session, and see you all. Bye.